This is a introduction to discrete structures for computing. In this video I want to take a little time to explain what the course is going to be about, how you're going to be evaluated in the course, and a little bit about what is discrete structures. So first of all, what does it mean to be discrete? Well, in the sense of mathematics, discrete means countable. That's all it means. So when you see this on a test, I want you to remember that. Discrete means countable. And if you think about what we're doing in the world of computing, everything is digital. Digital is countable. We try sometimes to emulate what it means to be continuous by using long digital numbers or long things after the decimal point, numbers after the decimal point going way out. But at any rate, whatever we end up with, it's still countable. The subject matter that we're going to cover in this course includes logic. So we're going to look at propositional logic and then predicate logic. Then we're going to go into things like combinatorics, how to evaluate a program for its projected runtime. This is going to help you make your programs more efficient by looking at things that run faster versus slower. We're going to have a project on that. We're going to look at set theory. We're going to look at functions and relations. We're going to look at mapping. We're going to look at trees. We've got a whole bunch of things we'll look at here, but they're all going to relate to different areas of in the School of Computing, to the different majors that you have. So this is a generalized course for all majors in the School of Computing. So, how are we going to assess this course? How are you going to be evaluated? Well, we have 3 tests. One of those tests is the final exam. The other 2 will be periodic through the course, and they are going to be online tests. You will have 2 attempts at those tests. The reason being that one of the things I have found over time is that students always ask, what's going to be on the test? What do I need to study for? Well, I think it's better for you to see it for yourself. So you get 2 chances on the test. Now what that means is that when the test is open, and it's open for approximately 3 to 4 days to give you a chance to work on the test, don't wait till the last minute to take it the first time. Take it the first time at the beginning when the test is open. That gives you a chance then to evaluate yourself and ask yourself, what is it that I still feel weak on? And go back and do a little research on that. That way, when you take the test the second time, hopefully you'll do very well. But that has a dual purpose. I know grades are important. When I was in school, grades were important. But in the long run, it's what you retain 5 or 10 years after you get out of school. So it's better for you to spend a little extra time in each segment of the course, making sure you understand the material. And that's why I give the test twice. So you have 2 chances. The final is also online. There are also 2 chances for it. It's cumulative, so it goes back to the beginning of the course, and it'll cover the whole course. Each one, all 3 of those tests count 25% each. So there's 75% of your grade. The project that you'll be doing will also count 25%. So it's very important that you get started on the project fairly early in the course. What you'll be doing is you'll be comparing a couple of algorithms for sorting. And it'll be your job to assess or project how long you think each one of those is going to take to perform, and which one is better. Maybe one is better at certain size databases and another one's better at larger databases. That's a big hint. But you want to take a look at those 2. Now you will be responsible for coding those in a language that you're comfortable with. We do not promote a particular language in this course. What we do is we give you those 2 programs in pseudocode, and we need you to write them in your appropriate language, whatever you're used to. So that's a little bit about it. The other thing that we want you to do is keep a log. And in the log, it's more than just your notes. It's really your personal evaluation of what it is you learned in each section. So as you go along, keep a log, and keep this log online somewhere so that you can transfer it to me. What I'll do is I'll look at the logs at the end of the term, or at the end of the semester, when you've taken your final, and whatever grade you get on your log can add up to 5 points to your final grade. Now your final test will be evaluated 0 to 100, but if you say get an 85 but you've been running A's on the other tests, it's a potential that that log could bring you up to a 90. So you want to do the log and make sure you get it to me by the end of the course. Now this course, for those of you that are online, is pretty much like online courses that you've been used to in the past. You will have readings and videos to watch during the week that the different subjects come up. What we've chosen to do, because we know that textbooks are a big expense to students, is we have picked material off of the internet, which you can access for free, which relates to each of the topics that we're going to cover. So as those things come up, do the readings, watch the videos, and then in most of these areas you will have a short quiz. Now the quiz doesn't count for your grade, the quiz is for you. Because when you get to the tests, you're going to want to make sure that you're competent in each one of these areas. So those quizzes are for your use to make sure that you're competent in each one of the subject matters. As you look at the syllabus, which is also online, it's part of your overview in the D2L course, you'll find that I've got a section here on the assignments and when they're going to be due, or when they're going to be, when you're going to work on them. In weeks 1 through 3, we're going to go over the course introduction. Well, that's what I'm doing right now. Plus propositional and predicate logic. Those two are key to being able to take real-world applications and reduce those or put those into a programming algorithm so that they're useful. So propositional and predicate logic, we'll spend time on that during the first 3 weeks. Week 5 and 6, we're going to talk about complexity analysis. Now, complexity analysis is looking at your algorithms, and this is the basis for your project. So in this period of time, you should start your project. But complexity analysis looks at code and comes up with a way that you can evaluate the time it's going to take for that particular algorithm to run. So that's complexity analysis. In weeks 7 and 8, we're going to look at sets, relations, and functions. This is not like you've seen necessarily in a math course, because in a math course, and I am a math teacher, when we talk about functions and relations, we're only talking about functions on the real number system. But we're not talking about the real number system. The real number system is not discrete. It's continuous. Now, what's the difference? Well, you cannot count the number of values between two values in the real number system. Or another way of putting that is, between any two numbers in the real number system, there exists another number, at least. Actually, infinitely many. But the real number system is continuous. There are no gaps. So you cannot count the elements. In a discrete number system, you can. And we're only working with discrete entities here in this class. Elements of a set are discrete. So when you look at a set of people, for instance, you can count the number of people. These are discrete things, and everything that we're talking about in the world of computing is basically discrete. So, sets, relations, and functions. Then we go on in weeks 10 and 11 talking about graphs and trees. And again, these are not XY graphs, the coordinate graph system. This is a different approach to looking at graphs because it's very helpful in setting up data and data structures. We'll relate this to databases and how they work, and what's the most efficient way to set up data. So this gives you some real-world tools to begin to look at how you would set up data for your applications. Combinatorics gets into combinations, permutations, different ways of counting. Very helpful in writing algorithms. That's our last main topic. And then we'll spend some time on reviewing for the final. You'll see on here also when the tests come up. So September 5th is when test 1 comes up. October 10th is when test 2 comes up. And then December 5th is when the final exam and the course log are due. And I've set up October 31st for when the project is due. So if you get your project done and get it in, this gives us time to really examine it. Gives me time to really examine your project because I really want to give you the best grade I can. Okay, so that's an introduction to the course. What you should do now is get started. Make sure you read through this syllabus and you understand it. And then get started on propositional and predicate logics and work through those and work through the quizzes and make sure you can do them. If you need to get in touch with me, please use email. That's the best way to reach me. And I will respond as quickly as I can. As we go through, obviously the classroom group will be meeting on Friday mornings at 9 o'clock. And I want you to have done the readings and watch the videos before you come to class, so that when you come to class and I start talking to you about this, we can have more of a conversation than a lecture. I do not believe in lecturing. I believe in conversations and interactions. So I expect you to have prepared for class by doing the readings and the videos. Come to class, and that way we can have much more meaningful interactions during the class period. So get started as soon as you can and make sure you keep up with the schedule.